In this video, we're going to take you through advanced number systems. So we're going back to number systems and looking at more advanced topics. So the four things we'll be looking at is negative numbers. So far we've only looked at positive, binary addition and subtraction, multiplication and fractions. Okay, so there's a fair few to get through today. So let's first start off with binary addition. Now, if you have two digits, it's pretty easy. Okay, so the first one here, 1 and 0, gives you 1. Same thing again there. Now 1 and 1 is equal to 2, so we all know that 1 plus 1 equals 2 in denary, and 2 in binary, and 2 in binary is 1, 0. Now we do exactly the same as what we would do in denary for a situation where we had 9 plus 1 equals 10. Well, if we were adding that up, it would be 0 carry the 1. So we do exactly the same here. So 1 plus 1 is 2. 2 in binary is 1, 0. So it's 0 carry the 1. Okay, so that's the carry there. Now, we could also get a situation where we have 3 digits, and that's the problem. That's why we need what's called a full adder. So we have 1 plus 1 plus 1. So 1 plus 1 plus 1 is equal to 3. 3 in binary is 1, 1. So it's 1 carry, there's the carry there. So it's 1 carry the 1. Okay, so this is all you got to remember that. But I mean, that's pretty straightforward. Now there's some simple cases here. If we're adding 10, there's 10 there, and there's 5 here. There are no carries, so it's just adding 1s and 0s and then adding 0s. So 1 plus 1 is 1, again another 1, and look at it, works out, it's 15. All right, nice. But we could end up with carries. So 1 plus 1 is 0, so that's the first one done there. Now this one here, 1 plus 1 plus 1 is 0. Sorry, let's start that one again. Now 1 plus 1 is 0 carry the 1. So we got the carry here. Now the situation is we've got that 1 plus 1 here, carry that plus that 1 is 1 carry 1. And we keep on doing that until we finally get this carry here. So 1, this carry plus 0 is just 1. All right. So that's the situation where you have carries there. Okay. So we got 15 plus 15. In this case, it's 30. Okay. Now you could just do these on your calculator, but what I'm going to be looking for is to make sure you got carries. Okay, so this one here, I'll just start you off and we're going to finish it. 1 plus 1 is 0 carry the 1. 1 plus 1 is 0 carry the 1. Okay, and then keep going. All right, so I want to see these carries here. So you spell carries? I hope so. Now, all right, so there we go. There's some more for you to do. Now, so far, we've only dealt with positive numbers. Okay. Now, when you declare a variable in C#, you've got options, and you declare something as an int. That's what's called a signed number. It can basically be positive or negative. Okay. You can also have unsigned numbers, and I can't remember what that is off the top of my head, but I could load up C#, but it'll take a while on here. You can have unsigned numbers as well, and they're only positive. So far we've only done unsigned, but now we're going to look at numbers that can be signed. Okay, it's up there. Uint. God, my notes are so good. I forgot how good they are. Right, now there's something we're going to be looking at here. Right, so this number here is equal to 6. Now below it, I'm going to write minus 7, minus 6. Okay, so this is going to be minus 6. Okay, this number here is plus 7. Below it, I'm going to write minus 7. Now I've got a little rule in there I'm going to be dealing with. This number here is plus 12. I'm going to write minus 12 below it. Now you'll always have to be told whether a number's either signed or unsigned. Now, the example tends to call them 2's complement signed numbers. Okay. Now, I can prove to you that that is -6. All right. Now, if I add up these numbers, I should get 0. Yeah. If that is really -6, add them up, I should get 0. So that's 0 plus 0. 1 plus 1 is 0 carry 1. 1 plus 1 is 0 carry 1. 1 plus 1 is 0 carry 1. 1 is 0 carry 1. 1 plus 1 is 0 carry 1. 1 plus 1 is 0 carry 1. 1 plus 1 is 0 carry 1. Now this carry here would fall off. It would go into what's called a carry flag. All right. But if we declare a number as 8 bits, we can't suddenly magic up another bit to store that. Okay, so it's fallen off the end. We end up with 0 as our answer. Now that would also work for this one. So 1 plus 1 is 0 carry 1. 1 plus 1 is 0 carry 1. 1 plus 1 is 0 carry 1. And it's going to go like that. Okay, and that bit falls off the end. So you can see there that that's it. Now, so that is -7. Okay. Now, so the next question is, well, how do you know whether a binary number is positive or negative? Well, we know that by this bit here. Okay. Now that bit there on the furthest on the left is called the MSB, most significant bit. Okay. Now, if I'm running out of space here, let me just get rid of this. I already said that. Right. So, if the most significant bit is 0, then it's a positive number. If it's 1, it suddenly becomes negative. Okay. So, so that means then all of a sudden, if we have a number that is, let's make a bit of space down here. Let's say we got this number here, 1, 2. Oops, let's start again. Right, 1, 2, 3, 4. 1, 2, 3, 4. Now that number could be, if it's unsigned, we put the column headers over there, 1, 2, 4, 8, that becomes equal to 2, 5, 5. But if it's signed, it's no longer that, it's equal to -1. Okay, and I'll explain how we can actually work out that in a minute. Now, so if I'm given a number like this -6 here, how do I work it out? Well, how did I get from there to there? Now, the method is find the rightmost one bit, which in this case is that one there. Now, and then everything to its left, going that way, is flipped. So notice everything up to including the rightmost one bit are the same. So these 2 bits here are the same, but then I flip that 1 to become a 0, that 0 to become a 1 afterwards. Okay. Now look at this one here. Find the rightmost one bit. Well, it's here in this one. So that remains the same. So everything to its right and itself would remain the same. So that 1 becomes itself. Then I flip all of these bits here. Okay, going down there. So just do one more. Find the rightmost one bit. Notice everything and including itself to the right remains the same. So those 3 bits are the same, and then I flip. All right. So that's how you flip from positive to negative. Now it also works the same way. All right. Now this is a negative number. If we say this is a signed number, we know it's negative because the most significant bit here is a 1. Now if I want to find out what that's worth, I've already told you it's -1, but let's have a look. So if we bit flip that, now that's not the technical term, but that's what I'm going to call it. So I bit flip that. So I find the most significant bit. I'll do it in green. Wow. Right, there's the 1 there. And then I flip everything to its right, left. Right, so I end up with 1 there. Then I could just put the column headers over that: 1, 2, 4, 8, 16, 32, and so forth. So it's 1. So that's equal to 1. So that must be -1. Now, all right, so in summary then, what you do then, if you've got a positive number, you want to convert it into negative, then you find the rightmost one bit and then flip all the bits to its left. Now, over the page there, that is essentially just saying that, right? So using 2's complement. 2's complement is just the method it's called that, all right? So if the MSB is negative, it's a positive number. If it's 1, it's a negative. Right, so find the rightmost one and flip all the bits to its left. Now, another way of looking at that, so let's have a look at this minus. We know that let's have a look at this one here. So we've got 1, 2, 4, 8, 16, 32, 64. Now, when it's a signed number, the most significant bit is actually minus. All right, so it's -128. Now, I'm not going to do the maths here, but if you add 64, 32, 16, 4 to -128, you get -12 as your answer. All right. Now, I find it easier just to bit flip that back into its positive form, so the bit flipping works both ways, and you get the answer that way. It's up to you. It doesn't really make much difference. Some things won't bit flip, like for instance this number here. Okay, now if I try and bit flip that, I just get the same thing back, but you can just say, well, what is that then? Well, that's 128, that column there. So we know that that is actually -128. So there are some odd ones there that don't really work too well, but that's the only ones. Right. So there's some exercises there. So use 8 bits 2's complement to represent -5. Now let me just do a different example. Let me just do one. Let's do -9. Should we do -9? Yeah. So let's do -9 using 8 bits. All right. So what I would do first is do +9. So that is +9. Notice I'm using 8 bits. Just double check that is that's +9. So that's equal to +9. And then all I do is bit flip it. Okay. So find the rightmost one. Now the rightmost one is at the rightmost point. Then bit flip everything else. So that all the zeros become 1s and all the 1s become 0s. Okay. So that is equal to -9. Okay. It's easy as that. All right. Notice the most significant bits there are different, so we know straight away if it's positive or negative. Right, there's some more for you to do. Notice that D here is a trick question, so I'm expecting some people to, or I was expecting some people to just do -7. As soon as they see the words all 2's complement sign numbers, they automatically assume, oh, it's going to be negative. No, they represent positive and negative. Now you may have noticed we've got a thing here. Now let me just think about it in 4 bits, and you can fill this in yourself. Now if I've got 4 bits, let's do it in this space here. Let's say I'm unlimited to 4 bits. Now that if I've got, let's do signed, unsigned. Okay. Now, if I have that to that, that's my range, isn't it? So I can go from 15 to 0. And that's 16 different numbers. Now, if it's 4 bits signed, now my range is no longer that. So remember, I can go from plus, now it must begin with a 0 to be positive, to that. All right, so that is +7, and it goes all the way to -8. All right, now what we've got is the same number of numbers. Okay, we've got 16 numbers, but it doesn't go as high anymore. but it goes below 0. So remember, if I'm doing a signed number, okay, 1111 is equal to -1. All right, so it no longer is the biggest number that you would have had if it was unsigned. So what I want you to do here is, you notice the range, so let's do it for 8 bits, please. Give that a go, and I want you to write out what is the range for 8-bit numbers there. So I want the lowest for the signed, and what is obviously the lowest for the unsigned is 0. Now, next bit is binary subtraction. Now, the good news is that you don't have to do binary subtraction. All right, all you do is add a negative to a positive. So here's an example. So I've got +10 here, -5 here. That's -5. Okay, all I did was 1, 2, 3, 4, 0, 1, 0, 1. That's +5. Bit flipped it, so it's 1, 1, 0, 1, 1, 1, 1, 1. Okay, so that's where the -5 comes from. Now, if I add those two numbers together, 1 plus 1 is 1. 1 plus 1 is 0 carried 1. 0 plus 0 plus the 1 is 1. And then 1 plus 1 is 0 carried 1. And what's going to happen now is I'm going to get all of these carries. This one falls off the end. But you notice the answer here is 5, which we'd expect. So your exercise here is to write out +7. I'll just fill in the first part for you. So 7 is 0, 0, 0, 0, 1, 1, 1. -1 is all the ones. And then all you do is add those up, and you should get the correct answer, which is 6. Now, it's important that you need to show your carries here. Okay, I certainly in the test would be expecting to see those, because obviously you could well, you know what 7 is, you know what the answer should be. I mean, I've written it out here to help you, but in the test it wouldn't. You could just write out the answer without actually doing any workings out. Okay, next bit is multiplication. Now, multiplication is something that you get taught different ways at school. This is the way that I was taught how to do it. All right. Now, shift and add. Okay, and this does make sense. Now, the way I do it, if I've got 354 times 23, all right. Now, what I do is I start off with the tens, or the one furthest over, or the most significant digit, if you like. Now, because that's in the tens, essentially I'm multiplying it by 20, so I need to add a 0 there, okay? And then it's just 2 times 4 is 8, plus, no, I haven't done it that way around. I've started with the 3, haven't I? So 3 4s are 12, so that's 2 carrying a 1, 3 5s are 15, plus 1 is 6. Is 16, so there's a carry 1 that I've not put in there. 3 3s are 9, plus 1 is 10. All right, so that's where that comes from there. Now I do the 20s, if you like. So I add a 0, 2 4s are 8, 2 5s are 10, so there's a carry there, down there, and 2 3s are 6, plus 1 is 7. Now I add those up, and then I basically get them. Now, the nice thing about that is, now notice what I'm going to do now is multiply 351 by 110. All right. Now, what is 0 times 351? Well, it's just 0. Okay. Now I'm going to do this one column here. So add a 0. 1 times 351 is 351. That's nice. Now I'm going to do this one here. Now add 2 zeros. So I'm shifting 1 times 351. Now add them up. 0, 1, 6, 8, 3. All right. So now the nice thing about that is that it is really straightforward, because notice I'm multiplying it by a number that's just ones and zeros, as it would be if it was binary. Now, so when you multiply them by binary, all you're doing is either just writing the number out that you're multiplying it against, if you like. That's right. And then you're shifting it. And then basically you do some adding. Now the exam questions on that are pretty straightforward. Now notice you potential here. You've got potential adding problems because you're adding 3 digits, so you could get a fourth one. You wouldn't get anything like that in an exam. All right. So when it comes to do binary multiplication, okay, I'm starting here with this one. So I've got a 1, so I'm just writing out this number again. I'm doing the 0 next, which I could just ignore that row completely. And then I'm doing the 1, so I'm doing shifting twice in this one, and then writing the top number out. Okay, I'm sure there's a technical name for them. Is it multi? I don't know, I can't remember. Okay, so there's another example there. This time it has a little bit of maths there. So this is 15 times 3, you should get 45. Right. So I know some of you do all sorts of grid methods of multiplication. I think they've only asked a question once about this. So on this one here, what I'd want you to do is 3 times 8. So you're going to have to write out. Now, what I didn't say, or I might well have done, we treat these as unsigned numbers. Okay, so we'll just keep them unsigned for now. All right. So the question should always really say where they are. So we have 8 times 3 multiply. So I'm expecting 3 rows, and then you add up those, and then you get your answer here. Okay. I'm not going to do that. Okay. Right. So now, for some reason, I don't know why, I don't put binary fractions in here, so we'll do that now. Don't know why. Didn't bother. Right, okay. So let's add okay. So binary fractions. Now we'll assume that these are signed. Okay. So if you see a most significant bit with a 1, then you know that it's a negative number. So let's start off with a nice easy one. So this number here, so I'm going to put a binary point in here. I'll probably call it a decimal point at some point. Now what does that number represent? Well, let's work out how we do that. So the column headers are exactly the same as before, 1, 2, 4, 8, going that way, but the column headers to the right of the binary point are different. Now they are half, quarter, and 8. So they're basically going the other way, but with the 1 over the top. Okay. Now you might think, well, why don't we start with a 1? Because 1 over 1 will be 1, and that would make no sense. All right. So half. So what we've got then is, what does that represent? Well, it equals plus 3.75, because we have the 3 there. Half and a quarter is 0.75. Now you can do you can leave it as a fraction. It's not a problem. I'm going to change color back to black now. Now let's do another one. Now let's do this one here. So this number here. Now the thing about this one is that we've got a negative. It's negative because the most significant bit here, you can see, is actual 1. All right. So what do we do? Well, we're going to have to bit flip the whole thing. Now, when you bit flip a fixed point binary, which this is, what you're going to do is you just ignore the binary point. All right. So we find the rightmost one, which is that bit there. Okay, let's try not to make that look like another one. So we just write it out. So I've got my first one, keep that in. Now flip everything. Now, so what does that equal then? Well, that equals 1.5. Okay, now let's just put the comments. That's a 1, 2, 4, and that's a half. Right, that's nice. So it's 1.5. Now the thing that a lot of people will do is they will forget. Yeah, that's 1.5, but this represents minus 1.5. Okay, so remember when you put your answer in, is that you make sure that you've got that around the right way. Okay, now, so here's some more for you to do. I don't know why I didn't put it on the notes, but right. So there's one to work out. 0, 0, 0, 1. That's a bit too easy, isn't it? But there you go, done that. Let's not do that. That's ridiculous. Too late, I've written it out there. If you can't do part B, then you might as well go home. Right. Okay. We're doing one more. And then 1100.1100. Okay, there you go. Right, so in summary, what do we have then? Well, we have addition. All right, now addition is pretty easy. Remember, only adding maximum of 3 digits at a time, so the maximum that you're going to get is 3, so that's 1 carry 1. The other thing, now negative numbers, that is crucial. You've got to understand that. All right, so if a number is signed, you would always tell you if it's signed or unsigned in a question. If the most significant bits are 1, then we know it's negative. If it's 0, it's positive. Now to go from a positive to a negative and vice versa, all you do is you find the rightmost 1 bit and then you flip it. All right, everything to its left, but not including that one. All right, then we have, there's the method there. Then we have the range. Binary subtraction is easy because all we do is add a negative to a positive. There isn't any need to do subtraction, which is nice and easy for a computer. So it's exactly the same logic that will be used for addition. Multiplication is basically shift and add for a computer. It's not difficult. That's the point I'm trying to make here. All you're doing is shifting a binary number. So this one here is shifted twice to get that, and then and then adding. So again, it's not a difficult thing for a computer to do. And then we have fractions. Now fractions, these are fixed point. We'll be looking at what I call floating point later. So the binary point is fixed in the number, and what we'll do is we go, right, okay, so we just column headers to the left of the binary point as normal, to the right go half, quarter, eighth, 16th, and so forth. All right, there we go. So that's the end of the video. It's quite long.